Okay, we are going to be doing a little bit of pre-teaching. This text assumes that you already know a fair amount of geometry. And I don't want to assume that you remember everything from geometry that you maybe got in 6th grade. I also don't remember exactly what you saw in 6th grade because I wasn't there. And so I want to make sure that, that I'm teaching some of the notation, some of the language that's going to be used in this section. This whole video, there's going to be no math problems. It's going to be all on language and notation, and that's a big part of geometry is vocabulary. So we're going to be looking at how to read some of these math symbols. Okay, so reading math. So we've got this symbol here, AB, with a line over it. And that line, it means we have a segment of AB, that line segment of AB. And so I'm going to kind of do an extra little thing here. This isn't in your notes, but I'm going to draw a picture. So a line goes on forever and ever and ever and ever in both directions. And any 2 points on that line, so I could pick the points here and here maybe, would be the line AB. And so the notation for a line that goes on forever and ever 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 is AB with a line over it with arrows. Now, if we just want to talk about a certain part of that line, so it no longer goes on forever. We're talking about a part of the line that stops right there from A to B, and it doesn't go on forever. We're just talking about from this point A to this point B, that line segment. We denote that with a line over the top with no arrows. And that's just part of the line. And now, going back to, come on, smoothboard, there you go. What they're talking about on this page, AB with no line over it at all, is the length of this line segment AB. What that means is we're going to take a ruler. If we take a ruler, and I think I have a ruler here, yes, here we go, and I measure this line segment AB. So that line segment AB is about 11 centimeters, give or take, about 11 centimeters from A to B, about 11 centimeters. So now we have a measurement. So the line AB just is. It just is. That's where it is. It doesn't have a measurement. You can't measure it. It just is. Line AB just is. However, once we've measured it, AB without a line over it gives us a number. Oops, sorry, not 13, but 11. And so AB has a measurement of 11 centimeters. And it's just in notation. So that's really what we're talking about is how do you read this stuff? So AB with a line over it and arrows, a line that goes on forever. AB with a line over it and no arrows means it's just part of a line and it starts and stops. AB with no line over it is a measurement. That's a number. We've measured it. We've assigned that segment a number of 11 centimeters. Okay. Angles. And so the next section here we're looking at is angle AB. And you see right before A we have that little angle sign. And so again, if I take what's called a ray, going from here to here, we'll call this from A, there we go, and another ray that goes like this, there we go. And I take that, I've created an angle. And we call that angle A. So angle A is just the picture that you're looking at. That's all angle A is a picture. You can't measure it, it's not how big is it, it's not how small is it, it's a picture, AB. Another way we can actually call that angle is if you had other points on there. So from here and from here. That could also be called angle BAC. BAC, because it goes from B to A and then to C, BAC. You could also call it the other way. You could call it CAB, cab. And that would go from C to A to B. So there's your angle cab, or BAC, or angle A. And there's 3 different ways we can name that picture. Now, just like with the line segment, we can measure that angle. And so we're going to measure that angle, and I use these protractors. I can use a protractor to measure the angle. So this angle is about 55 degrees, give or take. It's about 55 degrees. In fact, that's pretty darn close. I did a good job with that one. That angle is about 55 degrees. And so we denote the picture like this. That's the picture itself. However, if we're talking about how big that angle is, going back here, we're looking at this M. M is the measure of angle A. And so for this one, we would say that the measure of angle A is equal to 55 degrees. You can measure angles in different ways. You don't have to use degrees, just like you don't have to use centimeters. You can use meters, you could use lots of different things. But we're using angles, or using degrees, excuse me, in this class. We won't be talking about any other way of measuring it. But degrees is typically how we'll measure an angle. So that's some of the notation. Line segment AB, measure of AB. Angle A, measure of angle A. Okay, moving on. Triangles. So we're putting a couple angles together, 3 angles, triangle. And we're going to be looking at what it means for these 2 triangles to be similar to each other. Okay, so we've got these similar angles, just checking my time, similar triangles. And there's 2 ways to know if 2 triangles are similar to one another. They're not exactly the same. ABC is smaller than DEF, but they're similar. They're similar in the way that they're set up, right? One doesn't look like, one doesn't look like this, and the other like that. Those 2 that I just drew, those are not similar to each other. They're very different. And so these 2 triangles, ABC and DEF, are similar. And what happens is that if I look at, say, angle A here, and I'm going to draw a little loop or a little hoop there.
Mrs. Berg, call 5243. Mrs. Berg, call 5243.
Mrs. Berg is going to call 5243. We've got this hoop. I want you to go ahead and draw that in as well. Now, if we look at triangle DEF, which angle do you think matches with that angle A? Well, angle D is going to match up with angle A. Those 2 angles are at the top there. They both match up. And in fact, what's going to happen is in 2 triangles that are similar to each other, 2 of the angles are going to be exactly the same. A and D, the angles that correspond, it's called corresponding parts of the triangle, are the same angle. They have the same measurement. Angle A and angle D have the same measurement. Now, angle B here is different than angle A. So we're going to put 2 hoops, or 2 arcs. Angle B does not match with angle D. So angle D does not have 2 arches on it, or 2 arcs. Angle B is going to match with angle E. So angle B and angle E, they're going to both have 2 arcs. Because B and E, they correspond to one another. So their angles are going to have the same measurement. But A and E do not. So they don't have the same number of arcs. And that's just how we show it. Right now, again, we're not doing any math with it. We're just saying that this is what it means when you see these things. 1 arc means that they match with each other. 2 arcs means that they match with each other. I bet you can't guess what we're going to do with angle C and angle F. That's right, we're going to put 3 arcs on angle C and angle F because those 2 angles match with each other. They're corresponding angles. And corresponding angles are congruent. They have the same measurement. In fact, what I'm going to go ahead and have you write down right now is that if these triangles are similar, the corresponding angles are congruent. They have the same measurements. Go ahead and copy that down. The measure of angle A is equal to the measure of angle D. The measure of angle B is equal to the measure of angle E. And the measure of angle C is equal to the measure of angle F. And that's important, that if the 2 triangles are similar, the matching angles, the angles that match up, the corresponding angles, have the same measurement. Okay, pause it if you need more time. There's another part. There's another thing that we have to look at. And I'm sure you can kind of see it in your printout, but the sides. The sides are definitely not the same. The angles are the same. The corresponding angles are equal to each other. But the sides are definitely not the same. The sides are smaller. What ends up happening is that, and I'm going to put some numbers in here just to give you a frame of reference. If AB is, let's say AB is 6, inches. And DE is 12 inches. Okay, and I'd tell you that AC is 4 inches. Now, if these two triangles are similar, see if you can guess how long FD is going to be. It's going to be 8 inches. And if you look, from 6 to 12, it's twice as big. From 4 to 8, it's twice as big. And if I tell you that from F to E is going to be, I can't think of a good one here. I would just go with, we'll go with 10. Why not? This is actually not a good triangle, but that's all right. 10 inches. CB is going to retain the same proportionality, it's called, the same ratio, the same comparison. It's going to be 5 inches. And so what we call that is that the corresponding sides are proportional. And if you look at it, I'm gonna set this up before I write down any letters, that from A to C, so AC and DF, the corresponding sides, the sides that match up, we'd have 4/8. 4/8. From A to B, from AB and DE, those matching sides, we'd have 6/12. And from the last two then, CB and FE, we'd have 5/10. I apologize about the interruptions.
You have a customer waiting.
And in fact, they're equal to each other, because 4/8 and 6/12 and 5/10 are all 1/2. And so the corresponding sides, the sides that match up, are proportional. They all equal the same general ratio. In fact, that's what you're going to write down right here. That's what that means. AB over DE, those corresponding sides, 6 and 12 in this case that I put down, is the same fraction, is the same ratio as BC to EF. And it's the same ratio, it's the same fraction as AC to DF. Now again, at this point, we're not doing any problems. I'm going to do that in a different video. I'll show you how that works with a problem, with a problem that you'll see in your assignment. But that's the notation, and that's what we're going to be writing, and that's how you read these problems. Okay, next video we'll actually have some problems to work on.